Hi, have you ever had a nice looking image or even playing sequence of images in the level and it looked nice from a distance, but up close looked quite low quality and you had reached limit of maximum resolution? Well, then this video is for you. I will show you how to create a look of LEDs from up close so that your image, instead looking low quality, will look cool and unique. So let's get started. This is my reference image. If you ever seen advertisement large screens from up close, you would see these LEDs. This is what I want to recreate. So instead of then from up close we see low quality image, really blurry, we can see this. So this is my LED mask, which is RGB, and it's pretty low resolution, 256 by 256, and I switched compression setting to masks. And this disables sRGB color because we actually don't care about color, we're just using mask. And I created this screen. Very simple. So I have frame and then I have screen. So for the screen I have separate material. So I want to do it as a material function instead of material. This means that if you want to add this effect to any of your material, you will just add this material function and it will work. So it's really useful. So let's call it LED screen. While deselecting everything, I will add tick here to expose to library, which means then we can search and find it here. And then I will switch to plain preview so we can easier preview it. Okay, so first I will add our mask for LEDs. And I will use this gun image just for preview. I'm not adding tiling for this texture because I want it to cover whole my screen. It doesn't matter if you have it or not, this won't affect at all. Where we need to add tiling is for our LEDs, because otherwise it will be free only circles on the whole image. We want many of them. So let's have texture coordinates, multiply. We want all the circles to be not stretched, so we want to tile it uniformly. It means U and V, same number. So that's why we can use only one scalar parameter, we don't need two. Okay, so how it works is we're grabbing each channel and then we need to mask each channel from this image. Because each image, it's created with same RGB colors and then just combined, and with all this mix we're getting colorful image. And to mask it out we can use lerp or just multiply in this case. So we need red channel multiply with red channel from LEDs mask, then green with a green and blue with a blue. If I would preview that, see we have grayscale. If I will come close, so we have already lines. It's lines because I need to use our alpha then later to cut out into circles. But this is basically how much information, red information is in that image. Then we can preview how much green information, and this is how much of blue information. So now we mask that out, but as you saw, each channel now is grayscale, it's black and white. We need to add colors. What we need just to do is multiply again by color. So red, it means 1 in X. Then green, it means Y is 1. And then blue, it's Z is 1. Now we need to multiply this with each color. And now we need to add. So not append, but add. And if we preview, we have our image back. But if we zoom in, we can already see these little boxes. So now we need to cut out the circles. So we're using, again, multiply and alpha. So now we can see all the circles. Now let's add multiply and add scalar parameter. This will be our LED's intensity. I'll set it on 2. Okay, so this is working. What we need to do now is basically blend between having image with LEDs and having image as normal. So from the far away, we want to look at as normal. So for that, we need lerp, and this one will go into A, and normal image will go into B. Instead of dragging all over there, I will just create a root node from here. Okay, now let's create our blending. We can use distance blend, blend range. I will set this one to 250. And then start offset -150. And I will create a root node because I will need this in the multiple places. And we can use it here. Now what I want to add is when we will see from angle, I want that close to our screen would be these LED circles, but a little bit further away, it will be like more like a lines. We will clear this way a little bit noise created with the circles, and plus we'll add some extra nice details. I will take this tiling and create a root node. Then I need linear gradient. Then sine node. Then in sine, I want set it to 2. So if I will preview that, see it creates these lines. Then we need multiply this. So this is our mask, but now I want to control when I want this mask to kick in. So I will use our blend distance. So instead of creating additional mask, I will just using already what we have and just subtracting from the 0.4 and multiplying with our lines. And just to increase a little bit intensity, again, you can experiment with this. I will just add 2. We need another lerp, and we will add this one into A, and then our screen image into B, and then use this as a mask. You may see already these lines, and these lines, you see like it's still more visible. So we need to add another lerp, control that it's only based on angle. So let's add lerp. Into our A, we'll go this, and this one goes into B. Let's a little bit organize. And now as a mask, blend distance. Then we can add multiply, and this will be screen intensity. So this will go into emissive, and usually screens are pretty glossy, so it's up to you if you want to add this or not, but I will add these parameters as metallic, specular, and roughness to create this glossiness. You can skip that if you don't want. I'll set metallic maximum to 1. but initial 0.5, specular same, and roughness maximum 1, but initial 0.05. Now I will take this output and Ctrl+C, Ctrl+V it a few times. Let's rename this one as a metallic, and this one as a specular, and roughness. Then to have them in order when we will output them, we need to set this priority. So metallic should be first, so it will be 0, then specular, it will be 1, roughness 2, and emissive 3. Now let's connect. Now, instead of this image, I want to add input, so we can input any texture later on. So it will be function input, vector free, because it's RGB. And then what I need is break our float free, because we need to separate this RGB. And now I can connect from R channel into here, from green channel here, and B channel into here. Now we can delete this texture sample and connect directly from input into screen image. Take this screen image and connect it like that. So this one is already finished. What I want to do now is add little depth for the LEDs when we will see them from up close. For that, we need parallax occlusion. If you will search, you won't find it here. So then it means we need to look for material function call and then search here for parallax. Don't be scared of this big guy. We just need few parameters in here. I will disconnect this tiling from LEDs. I will still use it, but I will use it in parallax as well. So I will just have it separately. So LED resolution here. Now, first of all, we need texture. This is not texture sample, it's texture actually object. Is this one. And we need LEDs in there. And we can connect. Let's convert to parameter. Now we have height ratio. This is basically creating this depth, fake depth. You shouldn't go really with high numbers in there, otherwise everything will look really bad. Then we have minimum and maximum steps. By increasing them, you can increase quality of this effect, but at the same time you will increase cost of the rendering it. For such small things as LEDs, I'm not recommending increasing, so default is fine, I will leave that. Then for UVs, I need LEDs resolution. And then in height map channel, it's V4, so it's 4 channels. Let's hold 4 and click and connect. So with this one, we're basically saying in this texture, which channel to use as a mask, because in this texture could be 4 channels, RGBA. So we now need to say which channel to use. So I need alpha channel to be used as a mask. And so we can import different textures later for these LEDs. I will use same texture object in here. I can just connect it like that. And finally, maybe you don't want this effect every time. So I will set switch, static switch parameter, use parallax. And we need parallax UVs. So true, and it goes into UVs. And then if it will be false, we need this LED resolution. So it will be default one, which we used now. And with parallax, it will be true. Now let's create material, really simple one. And we can drag and drop into our material, our node created. Now let's add our image. So let's input this image. Actually, our input needs to be renamed. something like that. Screen image. Let's save. If you don't see it updated, you can just add again. So here is our screen image. And simple as that. Now we just need metallic, specular, and roughness, and emissive. Now let's create from our material instance. And I will apply it to our screen. Let's set base color to black. And quickly I will create another material for the frame. Just drag and drop in there. I'm not creating material instance, just for testing really quickly. So in here I will keep base color on the gray. Then metallic, maybe something like 0.8. I want shiny metal looking. Roughness, maybe like 0.1, like this. You can see our image from far looks fine. And then when we come in closer, we can see our LEDs. And we can see lines more there, and here it's proper LEDs. Then we can play with intensity of LEDs and resolution. And this gun is pretty high resolution. If I will lower it, so you see like it's 2K, make it like 512 by 512. You see from far, it looks really nice. We can even maybe make it bigger. So from far it looks nice, but then from up close it would be blurry, but then we see all these LEDs. Let's tweak a little bit. And with blend start and range, you can control how close you want to be when this LED kicks in. And if I will enable Parallax, we're getting additional parameters. And you can see now this LED is a little bit like bumps out. There is our height intensity. So this is what it does. And this is what step means. You can see these rings. If you would increase these steps, you would eliminate these rings, but again, it would be more costly. And it looks like a cool reflective screen. One more thing you can notice, that we only see LEDs where image is, so of our weapon, but nothing in here where is black. It's kind of not looking realistic. We can grab our alpha, which will have all 3 circles and plus multiplied by resolution, and we can multiply it with a specular. So let's multiply it. Now let's grab this alpha and create a root node. And now we see all these LEDs, even where it's black, but of course they're without color, and then the rest as it was. But if I will now go away from screen, still can see. Let's lower resolution. So even from far, I don't see here LEDs, our colorful RGB, but then black ones I still see, because we need to add our blend again. This blend distance. So we need lerp again. So this one will go into A, and then original without this alpha into B, And then into alpha, we will add again our blend distance. Okay, so now when we close, we see them, and when we're far, we don't. I would like to say thank you to my first supporters, Fish Tank Studios, Frazi, and Anas Naive. I appreciate your support. Thank you for your generosity. You can join our growing Discord community, where we like to discuss UEFN tips and tricks, showcase our work, and help each other. You can find link in the description or in the channel header. You can get project files on my Patreon or just buy me a coffee to support me. If you're interested in learning more about UEFN materials, coding, widget UI, and more, feel free to subscribe and click that bell icon to get notifications when new videos will be released. See you soon.